Please welcome Tim MacDonald.
Oh, okay, very good. All right, cool. I've been walking around this absolutely stunning city the last few days, and something that really struck me was the engineering here. Like, I don't understand how this city even exists. The houses, I mean, some of the houses certainly look like they shouldn't exist the way they're leaning and whatnot, but obviously there's a really strong engineering background here. And I see that in the code that we see from the Dutch community as well. And I linked those two together in my head that it's in the blood here, but then I realized it wasn't that at all. It's just because you've got so many rubber duck shops, and I don't understand why, but you're all obviously doing a lot of rubber duck debugging. So I'm here to talk about thoughtful performance, and this is performance that doesn't just impact most of your users. I want to think about all of your users. And I've also got a few nuts that I think as a community we need to crack. So some problems that I don't necessarily think we've solved yet that I think we need to come together and work out how we want to solve this as a community. So I'm just going to jump straight in. And the first thing I want to ask you to do is to do it at the same time. So I'm just going to show you some tips in the Laravel framework to improve the performance of your code. And hopefully you'll learn a couple of new things and we can dive into some interesting topics. Doing it at the same time. You want to send some HTTP requests, and we're PHP developers. We like to start at the top, and we like to read our code to the bottom, and that's the way we like it. So we send off a request, we send off another request, and we send off another request. Maybe these all take a second just to make numbers easy in my head. Don't like doing math live, and so that takes 3 seconds. Cool. So Laravel ships with a way that we can call HTTP pool. This functions on the HTTP facade, and this allows us to send requests at the same time. This uses curl's multi-function under the hood. And that means that we can refactor our code to something like this, and all of these requests get sent off and are processing and coming back all at the same time concurrently, which is really cool. So if each of these, again, took 1 second, then perhaps this takes just over a second. So that's how we can kind of improve the performance when we're sending multiple HTTP requests within a single code execution block. But that's not the only place you can do this kind of thing in Laravel. We've also got the process facade. And the process facade allows us to run scripts on the system. In this project, we've got some kind of re-indexing script, and we've also got a cleanup script. These scripts are completely independent. They don't impact each other. They can run in any order. So Laravel, again, ships with a concurrently method, and that allows us to run different scripts at the same time, just like we did with the HTTP pooling. And that means we can run both of these. Again, if they all take a second, rather than taking 2 seconds, we've maybe got that down to a second or so. Cool. But they're two very specific things. Cool, I can send HTTP requests at the same time, or I can run processes at the same time. What about other stuff? Well, let's look at another example where we're going to send an email. And the first thing we're going to do is an invoice has just been generated on our system. We've queued this up, and we are going to generate a PDF for that invoice to attach to the email. Next thing we're going to do is generate an Excel spreadsheet. Cool. And the last thing we're going to do, because you can't send an email without spamming someone, is we're going to get the latest marketing catalog and attach that as well. And this is an eloquent record. Now, we can't really do all these things at the same time. They're not HTTP requests. They're not processes on our system. So what we can use is we're going to call on our friends, our best friends over at Sparsy. And they've got this lovely little package that I adore. It's called fork. It doesn't work during HTTP requests. It'll only work on the queue because it uses PC Intel or something that I don't know how to use, but something special. And what I love about this is how it wraps your code up in that same kind of functionality as the HTTP pooling and the process concurrently. And I just feel safe doing this. Like, I'm a PHP developer. I get scared when someone's like, things are happening at the same time. I want things to just go top to bottom. But this makes me feel safe. I feel like this is a nice little warm blanket, and I don't feel like I can break this. So that means I can generate the PDF, generate the Excel spreadsheet, and retrieve the database record all concurrently at the same time, and improve the performance of generating all of those bits and pieces. Excellent package, but you don't have to take my word for it. I found this tweet as I was kind of having a look around what people were saying about this package, and if anyone else was kind of loving it as much as I do. And I saw that the Statamic team, along with some other performance improvements, introduced this package, and their build times improved by 1 trillion %. Now, I said, I'm not good at math, but that's a lot of percentages. So, bit of social proof for you there. Sparsy fork, awesome little package. So we can do things at the same time in PHP. Doesn't always feel like that's something we should do because we're not used to it, but maybe you can find some places in your app where you can do things at the same time. Next thing is to code impatiently. I hate waiting on a website with a loading indicator. I hate it. And I'm probably going to refresh, and that's probably going to make other stuff that takes longer. And you, just as much as I, hate to wait for applications, and your users hate to wait for applications. So I need you to code impatiently. And what do I mean by that? Well, we'll just use an example. These are all just examples. I want you to work out how you can kind of take this into your own app. But we're going to send off a request to get my website. Now, on a bad day, this could take up to 30 seconds before Laravel throws an exception. Laravel set some kind of sensible generic limits on how long a request can take, but they're not application specific. And if anyone is waiting 30 seconds for my website, dude, it's just not worth it. So what you want to do is you want to set a connection timeout, and you want to set a response timeout when you're sending a request with Laravel. And you can do this inline in your controllers, on the command line, wherever you're doing it. And that way you can give my website 5 seconds, still far too long to wait for my content. But that's not the only place I think you should do this. A lot of packages, they will resolve guzzle out of the container. And that means that they're not using the HTTP facade. So you're going to want to bind an instance of guzzle to the container with whatever your app is tolerable for just generic timeouts. So that's definitely a good tip there. Then you're going to have to look through all your packages, and you're going to have to work out which ones are sending HTTP requests and how do they customize this. For example, EC2, they don't resolve guzzle out of the container. They make you specify this in a HTTP option. These are the guzzle config options, but you have to do it manually. So go and seek those things out to work out how you can reduce those timeouts to something more tolerable for your application. 30 seconds may be tolerable for your application, maybe longer is, but you need to work out what that is. The other thing is with broadcasting, like we're sending events to Pusher from the back end so that they can then be sent to the web via webhooks, but we're not doing that to Pusher anymore, of course. We're doing that to Reverb. Yes! Yes. But we're using the Pusher config. We've got these client options here, and this is basically specifying, again, same options, but for the Pusher client as to how long it's going to take to send that request. If you're trying to do real-time activity, waiting 30 seconds for a response if Pusher is down, it's no longer real-time. So you've kind of missed the boat after 30 seconds, especially if they've gone and done other activities since. So of course, like I said, you can do this in line, but we've recently shipped a feature so that you can specify this globally for your whole application. So you can set some sensible defaults. You can then just send requests as you need, and they'll have those sensible defaults. And then in line, rather than decreasing those timeouts when you think it's problematic, you can go and increase them when you feel that maybe a service needs a bit more time. So code impatiently. Users don't want to be waiting 30 seconds, especially if they're visiting my website. All right. Next thing is do it later. So do you need to do this right now? Of course, you can push things onto the queue. That's kind of how we do things later. But I wanted to show you some other ways that you might be able to do things later in Laravel. Let's take this post. So we're going to delete this post. We've got a REST API. We're deleting this one. And then we're going to write this like admin style activity log. We're just going to write an entry in here to say that the post has been deleted. And then we're going to redirect the user back to the dashboard. But the user had to wait for us to write the activity log for this to happen. Now, this is like an admin-facing feature. This is a developer-facing feature, and the user had to wait on the line. All they wanted to do was delete the post. That's all they cared about. They didn't care about this activity log stuff. And the developer's like, I could push this out to a queue, but I don't really want to do that, so what can we do? Well, Laravel has this cool functionality called dispatch after response. I think this is a really cool function, and what it allows you to do is delete the post. Then you can dispatch a closure to run after the response, but the activity log work hasn't done yet. We haven't gone and done that database query or sent that over to Kafka or some event thing. I don't know what events are. And then we're going to redirect back to the dashboard. So the important thing here is that this code here is running before we write the activity log. So that means the user didn't have to wait for us to do this kind of admin-facing work. We just got the work done that they needed done, and we give them their response. So their browser is responding to that redirect, and then we go and do this admin work. And if anyone's used JavaScript enough, this is kind of like queue microtask. I think I've got that function name right. And I think this is a really cool pattern. I dig it. So let's take a look at another example that you might find useful or interesting, I hope. And that is with exceptions. You've probably written this code before. I've written this code a million times. We try and do some work, we catch an exception, we report the exception, redirect the user back, sorry, something went wrong. So the user is annoyed that something went wrong, and the user had to wait for us to report the exception. Now, why did they have to wait? Well, when I call the report, I'm sending off a HTTP request. That HTTP request may be talking to a service that is currently down. It may be talking to a service that times out. It may be using a HTTP client that doesn't have a low tolerance. It hasn't set like a 1-second timeout. So this is kind of annoying for the user because they've had to wait for that, and now they've had to basically, the thing has gone wrong, they've had to wait for it. No one likes to wait. So what can we do? Dispatch after response. So we'll try and do some work, we'll catch the exception, and then we're going to dispatch a closure to run after the response, but we're not going to execute that yet. We're going to redirect the user back. So we'll give them the bad news, but we're going to do it as quickly as possible. So hey, it's a little bit better for them. And then we're going to report the exception after the response. Now, you're not going to want to do this in all circumstances. There's going to be like really high critical areas where you've got to get that exception out or something like that. But hey, maybe this is a pattern that you can kind of embrace. And I think that this is an interesting pattern that, as a community, if we can come up with something to kind of make this a bit more of a concrete API, then I think having a first-party function like this in a package or in the framework or in your application would be really interesting, and it kind of unlocks some interesting patterns as well. Because one, it looks lovely, but two, too far, two, what that means is we've kind of delayed all these exceptions to the end. We might be worried we're going to lose them if we get a fatal exception. So what we can do if we have a first-party package or application implementation is log that exception, really quickly log it, and then at the end of the response we can send those long-lived HTTP requests. But we can also potentially batch them all up. So with Laravel Forge, we're working with servers all the time, and things just go wrong, and sometimes multiple things can go wrong within the one job. And when I say go wrong, it's kind of, we expect these things to fail sometimes. And so we actually end up reporting a few exceptions within the one task. And this allows us to kind of front load all the user's work and push all that developer-facing work to the end. Now, I love dispatch after response, but it only works in the HTTP response. So I would love if we had a way to do it after the job, after a command, and that way we really get that kind of queue microtask functionality from JavaScript. You might be thinking, Tim, app terminating, isn't that what that's for? It mostly is, but not quite, because it doesn't work in jobs. It only works in the CLI and in the HTTP request. So, I think it would be great if we could, again, collectively come together and crack this nut of having this kind of dispatch afterwards or report afterwards, and that would work in all different execution contexts and be agnostic of where your code is currently running. So that is doing it later. I don't know, that was a little bit of a deep dive and we went off track there a little bit, but hopefully that's given you some ideas of ways that you could change the order of execution to make sure you front load the user's work. Even if you're in a queued job, you want to make sure you get all the user's work done and push all that admin stuff to the end. Measure and act on data. We've all written this code. We're going to loop over some posts. We're going to access the post author, and we didn't eager load. We've seen this a million times. We've talked about all this stuff a million times. So we can do prevent lazy loading rather than throwing an exception, because I'd rather it just be slow than like throw an exception for the user. We're just going to write a log. Cool. We've seen this. We've read this blog post. That means that we now in this code, every time we do this loop, we're going to write a log and we're going to do a database query. Whereas before we were just doing a database query. So we've got a log, we can work out where the problem is, and we can go and fix that problem. So what about this code? This code doesn't do anything with lazy loading. I can eager load this, but I'm not currently. What I'm doing is I'm counting the comments right in the blade view here. And every time I run this, I'm doing a database query. Now, this isn't eager loading, so I don't get a log here. So this is pretty much exactly the same problem as what we had before, but I don't have a way to measure this or track this down. So let me show you a way that you can do a similar thing with lazy loading that you can with these kind of queries in the views. Because the views, for me, I often find once an app's been around for long enough and enough people have kind of worked on it, the views are where sometimes these database queries just get lost. Am I right? You just end up with these little loops and you just chuck a little query in there, maybe even in a JSON resource, not specifically a blade view, even in JSON resources as well. So when Laravel evaluates a view, when it executes that code, that blade, it does this process. It does this process where it fires an event to tell us, hey, I'm about to run this code, I'll do those loops, I'll run that database query, I'll execute and create that HTML. Then it goes and does that. And that's what this line here does. And then afterwards it says, hey, I'm finished now. I've done that work. That work is now done. I've finished doing all my blade work. So that means we've got this event before and after that query that I showed you was running that we can use to track when Laravel is executing a blade view. So what does that look like? Strap in. It's going to get a little messy, but we're going to get there. In your service provider, you can create a variable, and this variable is going to track when we're currently preparing a view, when Laravel is executing or evaluating that blade or JSON resource. Then we're going to listen to those two events, the one at the top and the one at the bottom, and we're just going to toggle that Boolean on and off. So we've just got a way to kind of keep track of when Laravel is executing that blade view. Then, and this is a little bit funky, but hopefully it's all tracking, it's not too much here. Then what we're going to do is we're going to listen to the database, and every time we do a database query while we're preparing the view, we're going to write a log here. This might get a bit noisy. You might need to use a lottery to only record this and log this every now and then, so it's not just flooding your system. But this is a way that, just like we did with eager loading, we can now track those database queries in our views. So we've got a bit more visibility into what's happening in our app and where some of those database queries can get out of hand. One more example. This code, I was a good boy writing this code. I've eager loaded, I'm using IDs, I have indexes, all these database queries really fast. Milliseconds, if that. Very, very fast. And yet, after long enough, I go and measure this code, and it's taking 5 seconds. And so the problem here is not that I didn't eager load. It's not that some database query is tucked away in a view somewhere that I've forgotten about. It's just that there's been so many database queries in this loop. There's just so many. So Laravel ships with a way to kind of track this problem as well. And that's when querying for longer than on the database facade. So what this allows you to do is specify a maximum time that Laravel should spend in the database. Not for one query, not for two, but for as many as it takes for it to get to 2 seconds. And then this closure gets run, just the one time. And this means that when we run this code, we do our database query every time this closure executes. And eventually, once it's reached 2 seconds worth of doing database queries, eventually it'll write a log as well. So we can track all sorts of things when it comes to our database. Now, I can't talk to you about improving the performance of databases. You need to go and buy Tobias's book. That book kind of blew my mind and helped me think about how databases actually work. So please go and buy that book. It's an excellent book. So the next thing, can't do a performance talk without talking about a cache, right? So let's talk about caching in Laravel. We've got a homepage, we've just built our app, and we're going to show how many transactions our website has done. We really want to show off how much sales we've made for our customers. So day one, this is $100, Day 3, maybe we've got 450. We're kicking along, things are great. This is loading really quickly, but eventually, calculating this starts to take a while. But we really want to show it on the homepage, but we don't want it to impact our users. So we're going to reach for probably my favorite Laravel API, which is cache remember. This API kind of summarizes so much about what I love about Laravel. I don't know if I can even express it. It's beautiful. So cache remember. We're going to cache the value of the total amount that we've made for our customers for an hour. And that means for an hour, all our users are getting really fast responses. But it also means once an hour, one of our users has a pretty crappy experience. They're going to have to wait for this value to be calculated. What's more is, if you've got enough traffic, if 3 users hit the web page at roughly the same time and the cache is empty, all 3 of those users are going to be impacted by this. So I've been thinking, I feel like this is another problem that we have where we've got a nut here and we need to work out as a community how we crack this. And I've just been doing some thinking. I don't have any solutions for you. I'm just here to talk some stuff. But one solution I've been thinking about is stale while revalidate, which is something that is offered in web browsers. It's a really interesting caching mechanism. I think it's relatively new, but maybe it's not. Maybe it's been around for ages. And I'll just give you a quick idea of how this works. So I'd imagine we'd build a macro on the cache facade here, do a similar thing to cache remember because, love that API. But there's going to be something a little different here. The thing that's different here is we've got 2 times to live. Sounds like a great movie name. Okay, so the first one is how long the cache is fresh for. And I'm going to steal Wes Boss's analogy here because I think it was perfect, which is imagine you've got a loaf of bread. You buy it, and this is some kind of futuristic bread where it's only really, really good. Maybe it's like covered in Vegemite. It's only really good for an hour. But you hold on to it. Like, it's not like you set a timer and you're like, all right, after an hour, bread's going in the bin. You know, you get it open, you cut a slice, and you're like, it's stale. Nothing some Vegemite can't fix, chuck it in the toaster. It's fine, I'll still eat it, it's okay, and I know I need to go and get some more bread. And so that's what happens here is when we hit this value is stale after an hour, but it's still okay. Like, I don't mind if the user gets something that's slightly out. They can still have it. They'll get that really fast response. And then in the background, we could do something like dispatch afterwards, that API that we were kind of dreaming up earlier. And we can refresh this value after all the work has been done within that request. So that means that the user gets the value really quickly out of the cache, they get their response, and then after that, this value in the cache gets refreshed to the most up-to-date version, and they don't pay the price. The users don't pay the price of having to refresh that value. So I feel like there's something here for us to look at. So cache, stale while revalidate, I think it's a really cool API. I think there's something in that for us. But we still have a nut to crack. We still have problems and places where you can't give someone a stale value, or you don't want to. You know, you really want that value to be updated and real, as real time as it can be. Not reverb real time, but like pretty real time. So how do we always hit a fresh cache? We know cache remember doesn't work for this particular problem. We know that stale while revalidate doesn't work for this particular problem. For that homepage example, it probably works fine, right? Because you're not too worried about that being a little bit out of date. But we'll continue on with the total sales idea. Where maybe we've got a dashboard where, you know, someone's on your back about this value needs to be updated. I don't want to like refresh my browser twice to see the right value. So I've been thinking about this. I imagine we could macro on to the schedule, kind of a warm command to keep our cache warm. And we'll refresh this value every hour, pass through this total sales class. We'll talk about these little pieces as we go. So this macro, it's just a closure here. So we're just calling a closure every hour. And that closure, it's going to receive a list of classes. They get newed up by the container, and then they get the warm method called on them. And so coming back to what it looked like in the schedule, you can see that's our macro there that's passing through that total sales class. But what does this class look like? Well, of course, it's going to have a warm method on it. And when we call that warm method, we're just going to force the value into the cache. We're not going to use cache remember here because we want to always force the new value in there. And we're going to leave it for a little bit longer than an hour this time. And because we're using the scheduler, sometimes like another job in the schedule might take a little bit of time, so it won't happen exactly on the hour. And Redis is like a millisecond out for times to live. So it's like right on point. So we need to make sure that we've got a little bit of leeway here for this thing. And then we're going to put the value, it's going to be the total sales, and that's coming from this resolve method here. And the resolve method, of course, just going to return the sales here. So that means that every hour, this value is being refreshed in the cache actively for us. Just not in, it's not, we're not giving any bad values. We'll just always have a good value in here. But how do we get the value? Well, we're going to reach for cache remember here. And this is going to mean that our caching class is resilient to our schedule going down, or to a job taking even longer than 10 minutes. And that way we've kind of got this fallback of like, if the schedule goes down, we're back to where we started, right? We haven't lost too much. Maybe this could use stale while revalidate, so it's even better for our users in that regard. So that's going to then be invoked. So then in our controller, whenever we want to use this, we just kind of inject it in there, call sales, and that value will be constantly warm in the cache. We'll get that constant updated value. So if you're using cache remember, or if you're using caching at all, have a look through your system to see where are places where things might be, we might be catering to like 99.99% of our users, but every now and then there's a user that isn't getting the best experience here. And hopefully this has given you some ideas of ways that you might be able to dig into this kind of thing. Isolate greed. Whew. Man, I feel like I've just been going and going. Okay, hope it hasn't been too much. This is the last one for us, all right? Isolating greed. We want to make sure that all our users have access to as much of the resources in our system as they can, but not too much. I want to make sure that there's an even amount, you know. Maybe some users get a better queue or something, or a more high value, more powerful queue system if they need work done. But even those high value ones, they should all kind of share that. We don't want one user to hog our database or to hog our caching system or to hog our web workers and use all of those web workers. So we're going to use rate limiting, of course. We're going to build this. We're kicking off our API, and we think 120 requests is pretty good. It's about 2 requests a second. Seems reasonable. No one really needs to use our app more than that. And that will help us make sure that that kind of smooths out the requests for everyone, and we don't let any one user just absolutely blast our system. So let's blast the system. We're going to make some requests against this 120 requests per minute rate limited endpoint. We're going to start at the top of the minute just because, again, math is not my strong suit. So we're going to start at some nice even numbers. We're going to do 1 request. Then we're not going to do any more requests. We're just going to sit back. Time's going to tick on. We're going to get 58 seconds, and we're still just chilling out. And then we're going to just smash this API. We're going to do 119 requests. Absolutely blast it. That's not great. Then we're going to do another 120 the very next second. So that means in 2 seconds, I've done 239 requests. Meanwhile, when I was setting that rate limiter, I thought, 2 requests a second, little bit out here. And I believe this is what we call gedogen. I don't know if I've said that right. And this is Dutch for illegal, but tolerated. So you can do it, but I wish you didn't. So what can we do here? Well, Taylor touched on this a little bit yesterday. With the release of Laravel 11, we're going to be able to do per second rate limiting. And Taylor demoed being able to just set the 1 rate limit, but Laravel also offers the ability to set 2 rate limits, which introduces some interesting ways of dealing with things. So this means with this kind of setup, we've kind of created this burst protection. They can still do 120 requests per second. I haven't taken that ability away, but I've said, 10 requests per second, please. Like, that's the max. So if we replay those requests that we did earlier, that means we've got 1 request at the top, and then we've just got 10 and 10. It helps smooth out those bursts so we don't have these massive spikes, and we can share our resources for all our users. I hope that was a good talk. I hope you enjoyed it. Thank you very much, LARACON.
Only have one question.
Okay, hit me.
Need to keep it briefly.
Yeah, let's do it. Let's do it. I'm ready.
So, first question. What's the main thing that you need to cache on Forge?
The main thing we need to cache on Forge. A lot of the output from tasks that we do on Forge. So on Forge, we run a lot of bash scripts, and those bash scripts have output, and quite often you want to have a look at them in the UI of Forge, but we don't want to be doing a connection to your server every single time you want to look at a specific output. So we cache those every time locally so that we only have to communicate with your server once, and then we can kind of hold on to it for a little bit, because those outputs never change.
Thank you.
No worries. Thanks so much.
No.
Oh, I thought you said there was 1.
But there's the anonymous.
There's always.
So the anonymous is wondering, will you ever eat Marmite again?
No.
Tough crowd.
Yeah, you know what? If I can help it.
What?
If I can help it.
Okay.
No.
Okay. Please, a big applause for Tim.